Hello everyone, today we're going to be looking at some multiplication patterns and what happens when we are multiplying and maybe even dividing integers. So I've got this big table and I know it doesn't totally fit underneath the DocCam, but I think you'll get the idea for what we're doing. So we're going to kind of start with some of the positives. So if you remember in elementary school how you'd kind of come together, use a horizontal and a vertical column and row, and then you'd write your answer in here. That's kind of what we're going to be working through. So this means 3 times negative 3. And that means 3 groups of negative 3. So I've got a group of negative 3, a group of negative 3, and a group of negative 3. So we've been using models for quite a bit. So what would 3 times negative 3 be equal to? So there's 9 tiles, and they're all negative, so negative 9. So let's do the same process as we move down through 2 times negative 3. So 2 groups of negative 3. And what do we have there? Negative 6. How about 1 group of negative 3? Well, that would just be negative 3. So you might be noticing something about these numbers. And then 0 times negative 3 would be 0 groups of negative 3, so just 0. All right, let's try our next one. 3 times negative 2. Well, we kind of already did that here. It would just be commutative property, and we're changing what number is negative. But let's try it out. So 3 groups of negative 2. So 1, 2, 1, 2, 1, 2. So how many do we have here? Negative 6. And then 2 times negative 2. So 2 groups of negative 2. And we have negative 4. And then 1 group of negative 2 would be negative 2. Again, are we kind of noticing something going on with these numbers? You might even beginning to see a pattern here in this column going down that you could make a prediction about what this bottom half will be over here. Let's do our last one and see if you can see the pattern that's happening. So 3 groups of negative 1. So 1, 2, 3. So negative 3. 2 groups of negative 1 equals negative 2. And then 1 group of negative 1 is negative 1. And then 0 times negative 1 is 0. And then same thing here. 3 times 0 is 0, 2 times 0 is 0, 1 times 0 is 0, 0 times 0 is 0. Okay, now let's take a look at the bottom. So to do negative 1 times negative 3. Now this is going to be hard to draw because I'm trying to remove 1 group of negative 3. Well, there's nothing to remove from. So I could start with 0 pairs if I wanted to, which we've been talking about. So I need 1 group of negative 3. And if I want to remove this 1 group of negative 3 and I take it away, what do I have left? 1, 2, 3 positives. So let's see if that works with our pattern here. Negative 9, negative 6, negative 3, 0. So I don't know if you noticed, but each time we're going down in the column, we're actually increasing by 3. We're getting 3 closer to 0. And then once we hit 0, now we're at 3. So can you make a prediction of what negative 3 times negative 2 would be? So if I want to remove 3 groups of negative 2, well, here's the problem is there's nothing to remove from, so I've got to bring in those 0 pairs again. So I need to remove 3 groups of negative 2. So here's a group of negative 2, here's a group of negative 2, and here's a group of negative 2. So if I take all those and remove them, what do I have left? A bunch of positives. 1, 2, 3, 4, 5, 6, positive 6. So does it look like our pattern is continuing? Yeah, I think so. Let's do our last one. Negative 3 times negative 3. So again, I want to remove 3 groups of negative 3. Well, like we said before, there's nothing to remove from here. So we have to bring in our 0 pairs. And so in this case, I need to remove 3 groups of negative 3. So there's 1 group, there's another group, and then here's my last group. And what do I have left? A whole bunch of negatives. 3, 4, 5, 6, 7, 8, 9. Now you might be noticing that the numbers I wrote on the bottom part are all opposites of the top, right? 3 and negative 3, 6 and negative 6, 9 and negative 9. And it does fit our pattern. So we're adding 3 each time, and then plus 3, plus 3, plus 3. So let's see if we can get this same pattern so that we don't have to draw models for the next ones. So -1 times -2. So let's take a look at our pattern here. Plus 2, plus 2, plus 2. So if I remove one group of -2, remember I've got to bring in some 0 pairs. If I remove a group of -2, all I have left are 2 positives. So it looks like our pattern of adding 2 is going to work. So let's try our next one, -2 times -2. Well, and remember we said opposites. 6 and -6 were opposites. 2 and -2 were opposites. So the opposite of -4 is +4. And then our last one, times -2. So what's the opposite of -6? That would be +6. So you might be noticing a negative times a negative will give us a positive answer down here in this quadrant. All right, let's look at our next column. So -1 times -1. So again, if I want to remove one group of -1, I take away that negative. All I have left is a +1. And look at where we got our opposite here that we talked about, because this is going -3, -2, -1, 0. So we're kind of going in consecutive order here. There's a 1. -2 times -1 is 2. And then what do you think that last one's going to be? 3. So if you can guess that one, that's great. All right, now we're going to fill in anything times 0 gives us 0. So I'm going to fill in this part. And then let's look at this right-hand side. Now, the top part you should be able to get. This is a 3, a 2, and a 1 here. 3 times 3 is 9. 3 times 2 is 6. 3 times 1 is 3. So I'm going to move through these kind of fast just to save time on this video. And you might notice these are the exact same digits. It's just they're all positive. So when you multiply a positive times a positive, you get a positive. Now let's take a look at our bottom ones. Here's 0. So we know those are all going to be 0 when we multiply. Here's our -1, -2, -3. All right, well, let's take a look. 1 times -1. So if you remember what we did over here, 1 times -1 was -1. Well, guess what? This is just -1 times 1. I just switched the order around. Remember, that's the commutative property. So in this case, that's going to give us -1. Now, is it fitting the pattern? We went 3, 2, 1, 0, -1. I've got my opposites, right? So if you had to make a prediction, what's -2 times 1 going to give us? -2. What's -3 times 1 going to give us? -3. So look, opposites, opposites, opposites. And our pattern is to decrease by 1 each time. Okay. Let's take a look at our next one. 6, 4, 2, 0. So if I multiply -1 times 2, do you think you know what that answer would be? Hopefully you're saying -2. Because over here, when we multiplied 1 times -2, we got -2. And we just switched the order here and changed what number was negative. So if you're seeing the opposites, 2 and -2, what would our next one be? Should be -4, should be -6. And then our last column here goes 9, 6, 3, 0. So maybe you're noticing the pattern that we're decreasing by 3 each time. So -1 times 3 would be -3. -2 times 3 would be -6. And then what would our last one be? -9. So the question at the bottom does say, describe at least one rule for multiplying integers based on what you see in the table. Well, there's a couple we could write, but I'm going to focus on a negative times a negative equals a positive. So -2 times -3 equals +6. All right, so that's what we're going to be focusing on. And the nice part about having this table filled out is you can always come back and refer to it. And what we'll do is we'll use a highlighter and make these nice and bright for you. So let's take a look at the back side of your note sheet. So if you're home, this note sheet is available. You can open it up or you can just follow along on a whiteboard. So let's take a look. 8 times 3, find the product. Well, parentheses mean to multiply. So 8 times 3 is 24. And then a positive times a negative. So when we had a negative times a negative, that was a positive. But if I come back in the table and look to see what happened when I multiplied a positive times a negative, I got a negative answer. So I have different signed numbers here. So that's going to give me 3 groups of -8 would be negative 24. So I could draw them out. Here's my three groups of negative 8. I just have a whole bunch of negatives. All right, let's take a look at the next one. Negative 2 times negative 4. Well, I know 2 times 4 is 8, so I always break it up into the steps. And a negative times a negative, remember that was the rule I picked out, is a positive. So you don't have to write the plus sign. You could just write it as 8. I just write the positive to reinforce that the answer is positive. 9 times 3, 27. A positive times a negative, so I have different signs, negative. So I could even say it as 3 groups of negative 9. And I just have a whole bunch of negatives. And then our last one has 3 numbers that we're multiplying together. So I'm going to start, remember commutative means you can start wherever you want. I'm actually going to start with my smaller negative numbers because I know a negative times a negative is a positive. So that's going to be positive 6. 6 times 10 is 60. All right, let's take a look at our next part. So it says write negative 20 as the product of a negative and a positive integer in at least 3 different ways. So I want to know what 2 numbers I can multiply together to get negative 20. So maybe you can pause and think of a couple. Or maybe you're brainstorming them now while I'm setting up my paper. So it says at least 3 different, so we'll put 4 down. Well, the easiest one would be negative 1 times 20. Now, you could switch that order and say 20 times negative 1. But I also know that I could multiply negative 2 times 10, and that would give me negative 20. And if I want to get really crazy, I could say negative 4 times 5, give me 20. Now, you could switch the order for any of these. You could switch which number is negative, but just as long as one of them is negative. All right, let's take a look at number 4. Number 4 says, which products are equivalent to 24? So in this case, I want to see what ones give me a positive 24. So again, I'm going to be looking, and I'm going to kind of zoom in here so you can see these a little better. So I'm going to start with my positive numbers here. You can start wherever you want. I'm just kind of breaking them up to either maintain positive or to make positive. 2 times 2 is 4. 4 times negative 6. Well, remember, that's 4 groups of negative 6. So I'm going to have a whole bunch of negatives. So that's going to be 4 times 6 is 24, and it was negative. And here I'm just going to move left to right because they're all negative. So 8 times 1 is 8, and a negative times a negative is a positive. And then 8 times negative 3 would give me, well, 8 times 3 is 24, but a positive times a negative when I have different signs is negative. So it's definitely not those 2. Let's look at this next one. 3 times 4 is 12, and a negative times a negative is a positive. 12 times 2 is 24, so that one works. Notice I have 2 negatives here. Before I had 3 negatives, and here I had 1 negative. But here I had 2 negatives, so a negative times a negative gave me a positive. Let's look at these last 2. So negative 6 times 2. So again, I could just go left to right, or I could, because of the commutative property, I can kind of jump around and say, well, negative 6 times negative 2 is 12. And a negative times a negative is a positive. So I use those 2 numbers. And then 12 times 2 is 24. So that one works as well. And then let's look at our last one. 1 times 3. So I'm going to jump over here to my negatives. A negative times a negative is a positive. 1 times 3 is 3. Times 8. 8 times 3 is 24. Now, that one works. Now, you might say, well, I didn't want to jump around. I just want to go left to right. That's fine. 8 times negative 1 is negative 8. And then times negative 3. So remember, a negative times a negative is a positive, and 8 times 3 is 24. So it doesn't matter what way you break them up because multiplication, you can use the commutative property. All right, that's where we're going to stop our video for today. Next time I see you, we're going to work through some of these word problems, and we'll do a little more practice. So I hope you're having a great day, even if you're not at school.